This is a bunch of logarithmic equation questions. And I thought, I guess it says calculator. C means calculator. You can use a calculator on these. I think you'd have to. All right, here's one. Log base 4 of x minus 1 equals 2. If I get log on one side and a number on the other, I can do the fishhook. This is 4 squared, which equals 16. And then that's going to equal the argument, equals x minus 1. I'll add 1 to both sides, 17, x equals 17. That's the answer for this one. Number 30, I've got log on one side, a constant on the other side, fishhook. Natural log is base e squared equals x. Equals, I will find my trusty, handy TI calculator here. And I've got e squared. Where is e squared? Wait a minute, I've got to clear it. Okay, now I've got it. E squared equals 7.39. I think it said round to the hundredths. Yes, 7.39. Okay. I'll circle them. X is 17, x is 7.39. Log of x equals 6. Again, log on one side, number on the other. That's log base 10. 10 to the 6th equals x. 10 to the 6th equals x. That's like 1 times 10 to the 6th. That is 1 million. So see, 1, 2, 3, 4, 5, 6. 1 million. Okay. So x is 1 million. Number 32. I have log on one side, constant on the other, fishhook. The base to the answer equals the argument. 3 to the 5th, 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243, equals x plus 5. I'll subtract 5 from both sides, 239 equals x. Next one, log base 3 of x plus log base 3 of x minus 8. So when I'm doing logarithmic equations, either get a log to the same base on each side, and then I can compare the arguments, or get a log on one side and a constant on the other. Well, here's a constant, so I'm going to have to combine these two. I'll do 33 down here. Log base 3 of x plus log base 3 of x minus 8. If they're added, I can put them in one log and multiply them. So this is log base 3 of x. Wait a minute. I wanted to put that inside the argument. X times x minus 8. And that equals 2. So now I do fishhook. Base to the answer equals the argument. 3 squared, which equals 9, equals x times x minus 8. What did I put a minus there for? It's x times x minus 8. I put that in parentheses, and I'm going to go ahead and distribute. This is x squared minus 8x equals 9. I'm just going to put the 9 over here. Equals 9. So now I will subtract 9 from both sides. X squared minus 8x minus 9 equals 0. I need some numbers that multiply to negative 9, factors of negative 9 that add to negative 8. How about negative 9 times 1? Negative 9 plus 1 is negative 8. Negative 9 times 1 is negative 9. So I have x minus 9, x plus 1 equals 0. By the 0 product rule, I'll set each one equal to 0. X minus 9 equals 0, x equals 9. I add 9 to both sides. X plus 1 equals 0, x equals minus 1. I subtract 1 from both sides. But now I've got to go and check if those both work in the original equation. Here's the original equation. If I put a negative number, log base 3 of a negative number, that's undefined. Cannot take a log of 0 or negative number. So the negative 1 does not work. The answer is 9. X equals 9. All right, 34. I'm going to make this a little bit bigger, so I have room to do these last ones. Okay. 34 I'll do over here. I think that says log base 4 of x minus log base 4 of x minus 1 equals 1/2. Well, again, I want either log on either side or just one log on one side. So I'll combine these. Let's see. Since it's negative, I will divide. It's log base 4 of x divided by x minus 1 equals 1/2. Now I will do the fishhook. 4 to the 1/2 power, which is the square root of 4, which is 2, equals x over x minus 1. The square root of 4 does not equal plus or minus 2. The square root of 4 equals 2. That's the principal square root. If you want to, go ahead and try this, where you do square root of 4 and make it equal to -2 and see what happens. All right, so now I will multiply both sides by x minus 1. 2 times x minus 1 is 2x minus 2 equals x. I will subtract x from both sides, add 2 to both sides. 2x minus x is x. Plus 2 on both sides equals 2. X equals 2. That's 34. What else do I have here? 35. I need to get more room for this one, so I'm going to bring it over here. Here's 35. So you can't do that on paper. People who are doing things on paper like it's the 1800s can't do what I just did. Okay, I've got a log on each side. Log base 3 of something equals log base 3 of something. Well, those arguments have to be equal. Those somethings have to be equal. 5x minus 1 equals x plus 7. Only if the logs are to the same base. 5x minus 1 equals x plus 7. I will subtract x from both sides. That's 4x. I will add 1 to both sides. Equals 8. Divide both sides by 4. X equals 2. How many more of these are there? That was 35. Okay, I guess I just have to do 36. And I will pull it down here. 36. 36. Go somewhere down here. All right, I want to have one log on either side. So this side has 2 logs. The left side, I will combine them. Since they're the same base, both log base 6 and a minus sign, I will divide. Log base 6 of 3x plus 14 divided by 5 equals log base 6 of 2x. And now, since I've got one log on either side, it's the same base, I can set the arguments equal. 3x plus 14 over 5 equals 2x. I'm going to need a little bit more room. I'm going to make it. I'm going to make more room. I will multiply both sides by 5. 3x plus 14 equals 10x. Subtract 3x from both sides. 14 equals 7x. Divide both sides by 7. X equal 2. There's the answer for that one. 36. And that's all of them. We've just done all of them.